Hello everyone, this is Vijay Lakshmi Sugnani from WinMaths. Now, today in this session, we discuss the concept inverse trigonometric function. Before going to study the inverse trigonometric function, we discuss some points. We have studied the inverse of a function f denoted by f inverse. We already studied inverse function that is denoted by f inverse. Okay. If a function has the f inverse or f inverse is exist if a function is 1 and onto. A function has 1 and onto condition, then there exists a inverse. Other than we can't write any inverse. Here there are so many functions which are not 1 onto or both condition. Hence we can't talk any of their inverse. We studied trigonometric function in our earlier class, but on that trigonometric function, 1 and onto functions not exist. A function that is for inverse, all trigonometric functions are neither 1 nor onto over their natural domains and ranges. For example, here consider a graph. Okay, here consider a graph for sin x, which is the trigonometric function. Here I consider only the sin x. This is trigonometric function. For this trigonometric function, we have taken the values in xy graph. X values, that is the values are taken in degree or radian. Here 0 degree means 0. 90 degree means in radian it can be written as pi by 2. Again 180 degree becomes pi. We know the standard result, that is 180 degree is equals to pi radian, because all the trigonometric values are studied in radian. That's why I am taken here for x interval, that is on interval x all the values are taken in radian. Again for particular y is taken as a real number. This is minus 0, minus 1, minus 2 up to so on. Again the values plus 1, plus 2, plus 3 up to so on upper set. Here for that particularly in general what we say sin x becomes 0. In particularly what we say sin x is equals to 0, that implies x value becomes n into pi. Here observe sin 0 will be 0. Again sin pi value becomes 0. 2 pi. For this function generally we can say for any x values we have taken for n is equals to any integer. For example it may be 0, plus or minus, whatever the value here taken here, that value becomes 0. It is shown in graph. Okay, then the function here, for example, we have taken the domain. Okay, all domains are real number, but these real numbers can be expressed in radian. For trigonometric values, we have taken the radians in that is real values taken as a radians. That's why we taken the domains. For the value pi, the value becomes 0, 2 pi 0, 3 pi 0. Hence we say f is not 1. Okay, again codomain has the real numbers. Okay, codomain is also have the real number. For this real number we take the values. For pi value we get 0. Again we have take the values pi by 2. For pi by 2 we get the result, that is for pi by 2 we get the result plus 1, that is 90 degree. 90 degree it has the range plus 1. Again for taken minus pi by 2, here for example taken minus pi by 2, that minus pi by 2 taken has the values minus 1. All the values, whatever the values we have taken in this domain, all the values are only taken the result minus 1 to 1. Then the range must be lies in minus 1 to plus 1. Other than minus 1 to 1, the numbers not exist. Okay, other than these two numbers, no values from minus 1 to 1, all the values are taken here only. The graph shows here because the range is minus 1 to minus 1. Okay, that's why the function is not 1 1 and on 2. We say that the trigonometric function sin x is not 1 1 and onto, but also we study inverse trigonometric functions here, because these inverse trigonometric functions plays an important role in calculus, for they serve to define many integrals. The concept of inverse trigonometric function is also used in science and engineering. That's why there are some restricted. It means we have discussed for a particular range. We discuss the inverse trigonometric function here for restricted values. Here we have taken in this graph. Here the values in this particular time, in this particular area. In this particular area, the values not repeated. Here from minus pi by 2 plus pi by 2, the values are taken here from minus 1 to plus 1. Therefore the range should be minus 1 to 1. Forever the values taken from minus pi by 2, we get the result in between minus 1 to 1. Let's see. Okay, here we consider in the chart. We consider the chart. Okay, here in this chart we have sine 0. Okay, see here in this graph. See here in this graph, the values 0. Okay, 0 degree. That is in terms of radian. It is in degree. The above values shows degree. This is in terms of radian. For 0 degree, values taken as a 0 degree, it becomes 0 radian. Here again the 30 degree. Okay, here 30 degree means pi by 6, pi by 4, pi by 3 and pi by 2 pi. Okay, because we know the standard result, that is pi is equals to 180 degree, or 180 degree is equals to pi radian. For these values taken for pi by 6, pi by 6 is lies between minus pi by 2, pi by 2. The value becomes 1.2. That is here 1 by 2, that is 0.5. Okay, again for pi by 4, the value becomes 1 by root 2. Root 2 value becomes, that is 1.44. 1 divided by 1, that is somewhere near to 1. Okay, for these values the range will be, or the graph shows that is minus 1 to 1. That's why for this restricted area, we define the trigonometric function. Since the domain of the sine function is the set of all the real numbers taken in radian, that is pi to pi, pi by 2, 2 pi, 3 pi by 2, 3 pi and some values, the range is the closed interval. Already we know the range. What do you mean by the range? Range is the subset of codomain. Range is the subset of codomain, as well as the range means for element or for any domain is related with codomain. Okay, for particular value. Okay, that shows the range. Here, since the domain of sine function and is the set of real numbers, and range becomes the closed interval minus 1 to 1. Okay, if we restrict its domain to minus pi by 2, then it becomes 1 1 and on 2, because from minus 1 to 1 the numbers are not repeated. For example, check in your calculator, sine 1 degree becomes, that is 0 0.009, and sine 2 degree 0.066, sine 3 degree. For minus 90 degree to plus 90 degree, we have not same number. They have, every element has the one and only unique value. Similarly, for in this chrome, this one is the one restricted range, okay, or one restricted domain. Again, here also one restricted domain, because there is no values change here. So there are sine function restricted to any of the intervals we have taken from minus pi by 2, pi by 2, pi by 2, 3 pi by 2. Again, for etc is 1 1, and its range should be minus 1 to plus. For this value only we have seen. Other than minus 1 to 1, nothing value will be taken, not taken here. Okay. So therefore, define the inverse of sine function in each case. These intervals, we denote the inverse of sine function by, we have denote the sine inverse function here, that is f of x is equals to sin x. Then this function is taken, that is y is equals to, replace f of x by y, then sin x. So sin is taken here for left side, that becomes inverse. Sin inverse of y is equals to x. This is the sin inverse function. Sin inverse function. Here for every element, okay, for every range, inverse means every element is related with domain. Okay, here inverse means that is a function taken from here domain to codomain, then their inverse must be taken here, that is codomain to domain. Okay, a function f from domain to codomain, then inverse means codomain to domain. Okay, now again the corresponding to each. So here whatever the values taken from minus 1 to 1 in the interval minus 1 to interval, we get the some ranges. That's why we take it as a function whose domain is minus 1 to 1 and range should be minus pi by 2. That range should be minus pi by 2 to pi by 2. Okay, therefore we can say it is the minus pi by 2, pi by 2, this is called the principal value. Principal value of range. Okay, principal value of range. Here from this, what we say, for trigonometric function we have discussed the graph here. Okay, graph for this. For inverse function we taken as their graph will be changes from here. The function trigonometric function, the graph is changes from a function x tends to y. For inverse function, that is taken from y tends to x, it will be changes. Okay, the graph of the function y is equals to sine inverse can be obtained from the graph sine y is equals to sine x by interchanging the x and y. This is the inverse graph, that is y is equals to sine inverse graph. Again similarly for this graph we can say domain and range. Domain and range for this function, inverse function will be sine inverse of domain and range will be minus 1 to 1. This is called the principal value of range. This is called the principal value of range, and this is called the principal value of range. This is domain and range for the sine inverse function. Again we have discussed the cos x. Okay, again discuss the cos x function here. For graph for cos x. Here the values are varies. In cos x function the values cos 1 will be, that is cos 1 value becomes when we say the cos value 1 at 0 degree, at 0 degree cos becomes 1, and at 90 degree, that is at 90 degree cos value becomes 0. 3 pi by 2, the value becomes 0. Okay, here we discuss the graph for cos x. F of x is equals to cos x, y is equals to, taken, replace f of x by cos x. In generally, what we say, cos x is equals to 0. When the graph value taken 0, it is at point 1. Okay, the value is 1. Here, for every value taken here integer, that is n is equals to 1, 2 into 1, 2, 2 plus 1, 3 pi by 2. For n is equals to 0, pi by 2. At 90 degree, at 90 degree, here in this degree, the cos value becomes 0. Okay, same to that graph of sine inverse. Here the restricted area, here we consider the restricted area, that is from 0 to pi. Here the restricted area will be 0 to pi. The values always taken in a positive, because in this particular range we get the principal values. In this area the values becomes varies. Okay, all values are unique here from 1 to -1. Then the range must be 1 to -1, the values whatever the taken. Okay, here pi by 2 becomes 0, pi the value becomes 1. Okay, that pi the value becomes -1. Again, taken the values, it will varies to 1 to -1. For cos 1 to -1 or cos 0 to pi, whatever the we have taken the values, all values are unique. In this interval we get the different values. That's why we taken the cos function, domain should be 0 to pi, and range must be 1 to -1. Okay, for inverse function we have taken the graph. Okay, we have considered the graph for cos inverse x. Similarly, same for that sine function, we have taken the function f from x tends to y, their inverse should be changes from y to x. Okay, here again this graph shows like this. From the for this particular values from -1 to 1, all the values are exist. So it is varies from 0 to pi. This is called, this range called the principal range. Principal range, that is domain and range of the inverse function will be, domain of this inverse function must be minus pi by 2, pi by 2. Then range will be the values. Okay, the values varies from 0 to pi, 0 to pi. For cos inverse function, the domain should be minus pi by 2, pi by 2. Range should be 0 to pi. Similarly, now we define other trigonometric function in terms of sine and cosine function. Okay, here cosec. Okay, first we consider cos x is equals to, it can be written 1 by sin x. Sin x becomes 0 when x is equals to n pi. Whatever the values taken as a pi, we get the 0. Here if we consider x is equals to 0, then our function cannot be defined here for n is equals to any integer, for x is equals to n5. That's why other than these numbers we have taken, we get a graph, or we have the definite solution for cos x. Similarly, for condition sec x, here graph we have taken. For here consider the sin x graph. Okay, for cos x graph, other than these particular area, the graph is taken for cos x is here. Okay, the graph is taken like this. Okay, the graph of this interval is taken except these values. The graph will be like this. Okay, this is sine graph. Inverse, that is cosec graph, will be other than these values, the graph like this. Okay, here for this particular value. Similarly for sec x. Sec x value other than these cos x value in denominator, the function exists. For tan x, sin x divided by cos x. For cot x, cos x divided by sin x. Some results are we have discussed. Okay, again we discussed the inverse functions, range and domain. Now here we observe this graph. In this table, one multiple choice questions will be asked for exam. It may ask for sine inverse, the principal value of sine inverse and the principal value of cos inverse, or sum of for these six values. It may asked in examination. It may domain or range. So this table should be remembered. So the easiest method to remember the table, here first we observe the sine graph. Okay, we already observed the sine graph. Here in this graph the ranges are should be -1 to -1. Here for inverse function the domain should be the sometimes it is called as the input. For these values we can get these, that is sine inverse of -1 value becomes minus pi by 2, sine inverse of 1 will be pi by 2. Here we here observe in this table. Okay, observe this in this table. Here taken sine function. Okay, that is 1 value, 1 means pi by 2. Here for 1 we get pi by 2. Again for -1 this is -1, that is minus pi by 2. Okay, our range should be minus pi by 2. Here from this, here our range should be minus pi by 2. Okay, now from this table we have observed the inverse functions domain. For -1 to 1 the domain should be, then range becomes minus pi by 2, pi by 2. For cos values, here also the domain should be same for 0 to pi. This is clearly close interval because the values are included here. This is one of the important. In that sine inverse function the values should be included because the values minus pi by 2, pi by 2, we have range -1 to pi. Okay, again for cos inverse these values are also included. Again cos here sine inverse x, that is -1 to 1. In that cosec inverse, the reciprocal of sine function will be cos x. Here other than these number except, okay, cos x means we say that cosec x function can be written as 1 by x. Here consider cos x is equals to 1 divided by sin x. Sin x does not equals to 0. If we consider sin x equals to 0, we can't define cos x function. That's why sin x never be 0. So sin x never be 0. It means on that ranges the cosec function does not exist. So except these values, okay, except these values we get the images. Okay, except these values we get the inverse function from real number 2, except this is closed interval. Here we taken minus. Closed interval means these two values are included because here it is open, excluded. Okay, real number excluded the -1 to 1, all the values are taken as a input. That time we get the range. Okay, that is minus pi by 2, except 0. Okay, except 0. This is the cosec inverse. Again, we have considered the sec function. Sec is equals to sec x is equals to, that is 1 divided by cosec x. Okay, sec inverse can be written as 1 divided by cos x. Similarly, here also, okay, here also we can say that is except minus 1 to 1. Same domain, real number except the open interval. In sine function as well as cos function, we have taken close interval. In cosec function, real number minus excluded. Okay, minus 1 to 1. Again here also real number minus 1 to minus. Here for 0 to pi minus pi by 2. Okay, again tan inverse function. Inverse function taken domain, that is real number and real number. Okay, for these they are ranges should be excluded of minus pi by 2 pi by 2. Other than these number, all the values are included. Okay, except minus pi by 2, that's why we indicate in open interval. For tan function as well as cot function, the values are indicated in open interval. Okay, the domain and ranges here. This table, on this table we accept one in multiple choice question for 1 mark. Okay, now how to solve the. Okay, in this section we discuss up to this one. In next section we discuss the problems.